Welcome. This session we will learn how to plot ILD for a truss member, which is a vertical member. So here I choose L2 U3, the vertical member, this vertical member. So I need to draw the ILD for this vertical member. Okay. So you need to take a section through the member, now the force for which you want to draw ILD. Okay. So obviously the other two members which will be cut is U2 U3 and L2 L3. So this is the section which is possible, which will cut three members. Okay. So by using method of sections, we will plot, or we will find this member force and then we will plot it. Okay. So the same section here is drawn in the two parts of the truss. You can see the right part where the member is cut here and the member is cut here and the other one, and the left part. Okay, right. We'll go by definition of ILD again. Okay, so the definition for ILD says when one unit load travels across the span, how the member force change, this any one chosen member force change, if you plot it, that is the ILD for that member force. Okay, so now I am interested in this member L2 U3 vertical member. Okay, right. So I take a section like this, right? Now these are the two parts of the truss after you cut the truss. Okay, so now let the unit load is on left part. Okay, so unit load is on left part of the truss. That means on this. Okay, so unit load is traveling on this. Okay, so it may occupy U1 and then U2 because the truss has only joint loads. So it occupies only U1 and U2 position. Okay, now when the load is to the left of the section, now you consider the right part of the truss, right part of the truss for the analysis. Okay, so for the right part of the truss, if you see, now you analyze this and get the force that is required. Okay, so now you plot the forces acting on the right part. Okay, so these are the forces acting on the right part. So you see this member is cut here, and the force acting on this member is vertically downward, and the member cut here, this is horizontal again, right? So this horizontal member is cut here, and this is the member force, this is the member force, and this is the member force, like this. Okay, and obviously the support reaction here. Okay, let us say this is RB. Okay, so now this force is named as FU2 U3. This vertical member force L2 U3, L2 U3. This member force L2 L3, L2 L3. Okay, so now my interest here is to work out for this member force. Force in L2 U3 I need. Okay, so now the right part of the truss is in equilibrium. So I need this force and I don't want these other two forces, they are horizontal. So I obviously apply sigma Fy is 0. Okay, to eliminate these two horizontal unknown forces. Okay, so now sum of all vertical forces equal to 0 on the right part. So what are all vertical forces you have? One is Rb, which is upward. Let us consider, say, upward force is positive. So I'll get Rb, upward force positive, minus the downward force FL2 U3, which is equal to 0. So this is the equation that you get. So from this, what I want is FL2U3, which is nothing but RB value. So what it says is, when the load is on the left part of the truss, this vertical member force is nothing but which is equal to the RB value. Okay, force in support reaction. Okay, now let us go to the other part of the truss. So when load is traveling on the right part of the truss, okay, now you choose the left part of the truss for the analysis. So let us plot the forces acting on this part. So this member is cut here, we have a force there. This member is cut there, so we'll have a force here, and this member is cut here, we'll have a force here. So this force Fu2 U3 is horizontal force here, FL2 U3 vertical force, and FL2 L3. These are the three forces, and obviously the support reaction, let us say RA. So these are the forces acting on this left part. Now you see this unit load is now on the right part. Okay, unit load is moving now on the right part. Okay, so now only you have three internal forces, nothing but member forces, and one reaction RA. Okay, so now you see how we find this vertical force required. Okay, so again applying sum of vertical forces 0, which is RA, plus both are upwards, right? So FL2 U3 is equal to 0. Okay, so now what is force in L2 U3 is equal to minus RA, which means it is negative force. That means the force which you assumed as tension is not the tensile force, it is compressive force. Okay, that means you can mention it is RA compression. Whereas here the assumed direction is correct and it is tensile force. So when the load is on the left part, the force in this vertical member is equal to RB and it is tension. When the force is, when the unit load is on the right part, the force in this vertical member is equal to RA and it is compression. Okay, so now how you draw those values that you found just now, you see. So I take a truss here, then we now draw ILD because we know all the force values for all the positions of unit load. Okay, so let us try plot the ILD now. Okay, so this is the reference line that I take. Now, so when unit load is on the left part, okay, that is like position U1 and U2. So these positions, okay, it is following RB value of force in the member, vertical member. This is the vertical member considered, this member is considered. So the member force is equal to RB and it is tension. So I plot compression above this line and tension below the reference line. Okay, you remember this, plotting the nature of the forces. So when the load takes these positions, okay, so this is the position that it can take, U1 and U2. It is following RB, right, which is equal to RB, nothing but RB. So first draw RB ILD for RB. So as I am drawing the RB ILD, you know how to plot ILD for reaction. Otherwise, you just go through the video that is made on how to plot ILD for reaction. So this is one unit. Okay. So now when load is on load is at U1, the value of RB is 0. When load is at U2, value of RB is this ordinate. Okay. Right. So only for these positions, this is the ILD that you are able to plot. Okay. Now, for other positions of unit load, for these U3, U4, U5, U6, U7, for these positions of unit load, okay, then it is following F L2 U3 is equal to RA. So RA ILD. So plot ILD for RA. Okay. Again, I advise you to just go to the video lecture on how to plot reaction ILD for reaction. So this is now RA ILD. This is ILD for RA. So for all these positions of unit load, the value of force in the member is equal to RA value. That means from here, the other part of the truss or ILD is this much. Okay. What about when load is between U2 and U3? Okay. So that you just join this. Okay. This join these 2 points. That's it by a straight line. Okay. So now you see this is tension and this is compression. This is the ILD for force in the vertical member chosen. That is ILD for force in L2 U3. So now you just look at the diagram and understand what exactly it is. So when one unit load starts from U1, the force in this member is 0. Okay, so when it reach U2, the force in this member is this much and it is in tension. This member force is in tension. As it cross this span U2 to U3, it will change from tension to compression. Okay, and then it goes, when unit load further moves from U3 to U7, it is going to reach to 0. Okay, so this is the maximum compression possible, maximum tension possible in this member. Okay, so this, and what are these values and how you get them? Let us say this is A. Okay, the span A. So from similar triangles, as this is 1, so this will become 1 by 6. Okay, this is 1/6 of the value, right? And how you get this value? Again, from similar triangles, it is like 4 by 6. Okay, 4 spans you have here. So these are the values that you are able to get for the ordinate values for ILD. Okay, so this is how you plot ILD and complete understanding of the ILD for one vertical member. Likewise, you can plot for any vertical member here as you just proceed with the same procedure, okay, which is given very clearly, right? Thank you.